Welcome to Ask and Learn.
So in this video, we're going to talk about question 4 from chapter 20, which says diagonal relationships in the periodic table exist as well as vertical relationships. For example, beryllium and aluminum are similar in some of their properties, as are boron and silicon. Rationalize why these diagonal relationships hold for properties such as size, ionization energy, and electron affinity. So if we're going diagonal down the periodic table, then we're going both from left to right and top to bottom at the same time. So let's talk about those individually. What happens when we go left to right and what happens when we go top to bottom? So if we're going left to right across a row of the periodic table, then we're gradually adding more protons to our nucleus, but electrons are being added to the same shell. You're not adding an additional shell. As you add more electrons, they're being added into the same shell, so you have the same shielding effects from those inner electrons, those electrons in your inner shells. Your valence electrons are experiencing the same shielding effects, but because you're increasing the charge, the positive charge in the nucleus by increasing the number of protons, then you're increasing the pull of the attractive pull that the electron feels towards the nucleus. And because you've increased that attractive force between the outermost electrons and the nucleus, the atomic radius decreases as we go from left to right. The electrons are pulled closer by that stronger force. And then if we think about ionization energy, as we go from left to right, ionization energy is the energy it takes to ionize an element, to remove one electron and produce an ion. So the energy it takes to remove an electron should go up as that attractive force that the outermost electrons are experiencing goes up. So because the pull of our electrons is going up, then the energy it takes to remove an electron, the ionization energy, is going up as well. Electron affinity, remember, electron affinity is the affinity that an atom has to attract an additional electron. Electron affinity will go up as the pull of that nucleus on those outermost electrons increases. So it also increases as we go from left to right. So now let's talk about when we go from top to bottom on the periodic table. So as we descend a column in the periodic table, we're adding an additional shell of electrons. We have our valence shell is further away from the nucleus, and you have more electrons between your valence electrons and the nucleus. So because of that increased shielding, the pull on electrons decreases as you go from top to bottom. And because of that, because you have less of a pull on your valence electrons, they're further away from the nucleus. So your atomic radius increases as you descend the periodic table. And similarly, because your pull on the outermost electrons has decreased, you've decreased the energy it takes to remove one of those electrons. And because the pull on that on those outermost electrons has decreased, then you've also decreased your atom's ability, your atom's nucleus's ability to attract an additional electron. So electron affinity and ionization energy both go down. So what we're seeing is that while from left to right, our pull on our outermost electrons goes up, from top to bottom it goes down. So these opposite effects kind of counter each other. And the same goes for the other properties, for atomic radius, for ionization energy, and for electron affinity. Because going left to right pushes it in the opposite direction than going top to bottom, then we end up with similar properties for elements that are diagonally adjacent to each other.